Hello everybody, it is Miss Hester. I'm going to make a little quick review of some of the main topics that will be covered on your DCP. And I wanted to just kind of go over some stuff because I know we went over it a little bit faster because I wanted to give you all time to work on your projects during class. So we're going to talk about some of the main topics here. For these first ones, I know for most of my classes I did 1A, so I'm going to do 1C for funsies. So domain, again, is all of the x values. So as I'm reading left to right on my graph, I notice that I have arrows. So that means as I'm going left to right, I will never ever stop seeing a graph, no matter how far I go. So what that means is that's that special little phrase, all real numbers, or the fancy R, okay, for domain. Now range is all y values. So as I read my graph bottom to top, this way I see where I can see a graph, okay? And I notice that I cannot go above 6 because I don't see a graph anywhere up here. So what that means is y, since we're dealing with range, y values, is less than 6. Now, it will be a less than or equal to 6 because if we notice, even though there's not like a coordinate point there, a little dot showing that there's a point, because we read left to right, we have to go through that point to be able to get to this right side of our graph. So it will be a less than or equal to 6 because we have to pass through that y value of 6 to get to the rest of our graph. Now, for a min-max, here we have a maximum because we see a peak, we see a highest y value. We cannot go past this y value. So we will have a maximum, and our value at that maximum is 6 because we cannot go above 6. And then our vertex will be at that same point. But for a vertex, I'm always looking for an xy coordinate. So I will have a 3, 6 because I have an x value of 3. And I have a y value of 6. Now, the axis of symmetry, I know a lot of y'all talked about in Algebra 1, but it is an imaginary vertical line that goes straight through our vertex and splits our graph in half. And the equation for any vertical line is x equals a number because it is telling us I have all of the y values at this particular x value. Okay, I will never change my x value, but I will have all of the y values along this vertical line. And that is why we will write it as x is equal to 3, not 6. Because it will share the x value of our vertex. Because our vertex is the very middle of our graph. It's that middle point. It's either the peak or the valley of our graph, and it's the very middle of our graph. So it will share our same x value. All right, continuing on down, that's all I really wanted to talk about for this section. This section's, I think, the one of the easier ones. But I want to talk about this. So since y'all are not able to use Desmos, if I were to give you something like this, where I just give you an equation, I'm going to show you really quick how to graph this in your graphing calculators. So I'm going to pull up my handy dandy calculator. Let me pull it up. Make it a slide over. Sorry, I'm moving around a lot. Okay, so what I'm going to do is I am going to use my y equals function. Okay, so that top left button, I'm going to type in y equals. And then I see on my graph over here, I have a negative sign before I type in my bars. So I'm going to type in my negative sign, and then I'm going to type in my bars, which is math. So this white button right under the alpha key. I'm going to hit the right arrow key once, and I'm going to go to num. Okay, and that first option is ABS, and that stands for absolute value, and that gives us our absolute value bars. And then we will hit our X button, which is that guy, plus 3. Now, to get this -5, we have to go outside of our bars, so we're going to go outside, and we're going to type in -5. Okay, and then from there, we'll hit the graph button up in the top right, and we'll get a graph, and we'll work it very similarly to what we did with our previous problem. Okay, and imagine there are arrows on that calculator. I know there aren't, but imagine that there are. So our domain would still be all real numbers because as I go left and right, I cannot stop. And I notice that I may not necessarily be able to see as clearly what my, what my vertex is at. So there's a way on your calculator that you can find your vertex. So you're going to hit second, which is the blue button, and then the button that says trace. It is to the left of your graph button. And if we remember, our graph had a peak, so it had a maximum. Okay, so I'm going to hit enter, and I'm going to go to the left bound. My calculator asked me my question up at the top because my calculator's weird, that I'm going to go to the left of my point. I'm going to hit enter, and now it's going to ask me for a right bound. So I'm going to go to the right of my point. I'm just kind of telling my calculator where I want to look. Okay, so my max will be at this point right here, and I'm not sure why it didn't work there. Let me take a look and see. So I want to go left, I want to go right. I guess it's not letting me. Well, either way, on your calculators it'll work. But this guy is at -3, -5. Okay, so our y value, our vertex is -3, -5, and I don't know, again, why my calculator is being dumb. But our range is everything below 5, because as we read bottom to top again, I see my graph everywhere below 5. So we will have a y is less than or equal to -5 as our range. And then again, we have a max here at -5, and our axis of symmetry will have the same x value as our vertex of -3. Okay, so again, you'll use your calculators, and then on DCP day, if you guys do have question about how to use the calculator, please let me know, and I will come and help you. I know that we've we've used Desmos a lot this year, and we haven't used the TIs too much, so I will definitely help you out with those later or during the test if you need to. Okay, so moving on down to our transformations. So I know that we went through 3A with most of my classes, and I know some of y'all I didn't, which I'm sorry about. But we're going to do a quick crash course on transformations. And I'm just going to kind of remind y'all, I'm going to go back out to, I think I'm just going to select this guy, and I'm going to talk about how transformations are going to work. I think it's in this one. No, it's not. Maybe it's at the top. There it is. Okay, so a while back, and I know I'm picking your brains a little, but a while back we talked about this reference sheet that we had to talk about all of the different transformations we'll have. Okay, we have an A, B, H, and a K. Those are our 4 variables that we have to quote-unquote play with when we're doing transformations. What I want you to know, negatives will always cause reflections. Okay, A and B will cause shrinks or compressions and a stretch. Okay, whether they're horizontal or vertical depends on where they're located within the parentheses. H and K will both be shifts. If it's inside the parentheses, we're dealing with H, which means we're going to go right or left. And then if we're dealing with K, we're going to go up or down. Okay, so that was a quick reminder on how that works. So coming on back here, I'm going to do 2 of these with y'all. So a vertical stretch by a factor of 3 means that I'm going to be playing with A, because I have, I'm on the outside because I'm vertical. Okay, and this means that A will be 3. Okay, and again, I have that general form of my absolute value equation right here. Okay, so my A is 3, and then I have a horizontal translation to the left 4. And remember that whenever we're doing left, we always have that opposite issue, but H is -4, and I'll show you how it's going to look opposite here in a little bit. And then the easiest transformation of all is a translation up 5. Okay, and that's just adding 5. Okay, so K is equal to plus 5. So all we're doing here is we're putting all of our pieces together. So I have 3 in for A, and then I have my bars. And if we notice, we didn't have any kind of horizontal stretch or a compression at all. So B didn't change. We didn't touch B at all. So I'm not even going to include a B. I'm going to have X, and then I'm going to have minus that -4, okay? And then I'll have my +5 out in front. So when I simplify this down a little bit, what we notice is when we have a double negative inside of those parentheses, we're going to have x plus 4. Okay, so that is why everything inside the parentheses kind of flips around, because horizontal transformations are weird. So that is how we would kind of put that together. What I recommend whenever you're doing transformations like this is go piece by piece by piece so that you're able to identify what all is happening. So I'm going to go ahead and do the next one with y'all. So reflection over the x-axis, okay, means I'm going to have a negative out in front of my a. So I will have a negative, and then I'm going to have my a. Okay, and I don't think we're going to have an a value here, but we will have a negative in front of the a. Okay, now horizontal stretch by a factor of 5. If y'all remember, I said a second ago, everything in horizontal transformations are weird. Okay, so if we have a horizontal stretch by a factor of 5, always think of those stretch factors or compression factors as a fraction. So if we have a whole number, 5 over 1, we're going to flip that over, which means our b, since we're a horizontal stretch or compression, will be a 1 over 5. Okay, again, horizontal transformations are really weird, so we will flip over our fractions. And then, of course, again, our easiest one is down 3, so k is -3. So putting all of this together, again, I did not receive a new a value like I did over here. I only received that I'm going to have a negative in front. So I don't even have to write I don't even have to write anything for a. All I know is I'm going to have some sort of negative out here. Okay? Then I'm going to draw my bar, and I'm going to put my 1/5 in front of my x because that's where my b goes. Okay? And then I'm going to have my x, and I didn't shift left or right. Okay, I didn't say I shifted left or right, so I'm just going to have that inside the parentheses. I'm not doing anything to it. Okay, and then I will have my -3 out on the back end. Okay, so again, piece by piece by piece, identify which variables you're messing with, and make sure to remember that horizontal transformations are wonky. Okay, so moving on down. This is pretty much the same idea, but with these, there's no stretches or compressions because horizontal compressions and vertical stretches mean the same thing on a graph, or they look the same on the graph. And then a horizontal stretch and a vertical compression, again, mean the same thing on a graph. So I didn't want to include those here because it's hard to tell which one it is. So I only included shifts and reflections here, and it's pretty much the same thing you're doing with these 4 examples up here. You're just given a graph. And I want to note that this grayed out graph is your original parent function. Okay, so our grayed out graph, this is the original. Okay, and then this guy is your new. That's a terrible new. We're going to rewrite that. New. It's still terrible, but it's better. Okay, so it's the same thing. It's just using a graph instead of a description. All right, moving on down. So this is what we've been doing for like 2 weeks. I'm not going to go over this one. I think I'm going to go over this one. Yeah, I'm going to go over this one. But we've been doing this for 2 weeks. If you don't know how to do this by now, listen up. Okay, so a bakery sells 3 types of pastries: muffins, croissants, and danishes. What do we think our 3 variables will be? Drum roll, please. It is X, Y, and Z for muffins, croissants, and danishes. Okay, the cost of a muffin is $1.50, a croissant costs $2, and a Danish costs $2.50. One day, the bakery sells a total of 150 pastries, and the total revenue for the day is $300. Additionally, they sold 20 more croissants than muffins. Okay, how many muffins, croissants, and danishes did the bakery sell that day? Create a system of equations, convert to a matrix, and solve using the calculator. Okay, so let's talk about each piece of information we're given. So first off, we're given cost of each item. Okay. Okay, so we have muffins is X, so we will have $1.50 X. plus 2y, because that's 2 our croissants, and then we'll have 250 for our danishes. Now, our total revenue for the day is $300. Again, with systems of equations, we want all of our equations to kind of correspond. So we want money, 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 money. Okay, and the only other piece of money information that we're given is that $300. Okay, now, how we figure out what to use for the rest of the equation is our question's asking how many muffins, croissants, danishes did the bakery sell that day. So I want to know how much of each item I sold. Okay, and I know that I sold a total of 150 pastries. So what I can say is hey, X plus Y plus Z is equal to 150. Because if I sold X muffins and Y croissants and Z danishes, that should add up to 150 pastries because all of these are pastries. Okay, and then our last piece of information talks about 20 more croissants than muffins. When we're talking about something that is 20 more, we are adding. Now, what I want to specify is which one are we adding it to? Are we adding it to X or are we adding it to Y? So I know I'm going to have X is equal to Y something, but which one will I add 20 to? Okay, so it told me, additionally, they sold 20 more croissants than muffins. Okay, so if let's say I have 10 muffins, I would have 30 croissants. So I'm adding 20 to my muffins. So I'll just put 20 plus my X over here. Now, the issue with this, before I can go to the matrix, is I have X and Y on both sides over here, or on both sides of the equal sign over here. And I notice that up here, my X's and my Y's are both on the left side of my equal sign. And then my number is on the right side. So I'm going to do some rearranging. I'm going to subtract Y from both sides. So I will have 20 plus X minus Y is equal to 0. And then I have to move this 20 over because all of my other constants are on the right side. So I'm going to subtract 20 from both sides, and I will get X minus Y is equal to negative 20. So now my three equations will be this guy, that guy, and this guy. Okay, so from here we'll go to the matrix. So we'll have 1.5, 2, 2.5, bar 300. Then we will have 1, 1, 1, 150. And then we will have 1, negative 1, 0, because we didn't have a Z value on that last one, negative 20. Okay, and from there you'll plug into your matrix just like what we've been doing. I'm going to pull up I closed my calculator for some reason. We're going to pull up our calculator again. Okay, so now from here we're going to pull up our calculator, and I'm going to go second matrix. And I'm going to go into edit, and I'm going to edit A. And I notice that I have a 3x4 matrix because I have 3 rows and 4 columns. So then I'm going to have 1.5, 2, 2.5, 300, 1, 1, 1, 150, 1, negative 1, 0, and negative 20. Okay, and then from here we'll hit second mode to get out of there. We will have second matrix again, and we're going to go over to math. We're going to scroll all the way down to the double REF. Not the single REF, we're going to do the double REF. Okay, we're going to hit enter, and then we'll go second matrix, and then we're going to hit the matrix that we used.
Don't panic if you're stuck with your math homework. Just grab your smartphone.
Y'all don't do air math.
Air math.
Don't do it. No. Okay, so then once we're there, hit enter, and we get some nasty numbers. Let me double check my math here. You always want to check when you get something nasty like that. You always check it just to make sure you're all good. All right, everything looks good, so maybe that's just how it's going to look. Okay, so I'm going to round down to just what roughly it is. So our new matrix is going to be 1, 0, 0, bar, 0, 1, 0, 0, 0, 1. So then we'd have 43 and 1/3, 63 and 1/3, and 43 and 1/3. Okay, so that means we sold roughly 43 muffins, 63 croissants, and 43 danishes. Okay, so that's just roughly, some of that might be off, but that's okay. So That's generally how we would do that. And continuing on down. And you would do the same thing here. It's just it already gives you the system. You're just converting it into a matrix and then using your calculator again to find the solution. So I'm not going to go over that because, again, we've been doing that for 2 weeks. All right. Absolute value equations. All right, let's talk about this. So absolute value equations we have not talked about in a hot minute. So let's talk about it. One of the most important things to remember is, everyone say it together, absolute value equations can never be negative, okay? So up here, and I think I talked about this with most of my classes, absolute value bars are by themselves. We're equal to a negative number. No bueno. No solution, so we don't have to do any work. Woohoo. Okay. All right. However, something like this is a-okay because I notice that I do not have my absolute value bars by themselves. They're that -3 out in front or out on back. And I'm going to add 3 to both sides so I can get my bars by themselves, because I can't determine if I have solutions or not until I get my bars by themselves. And if we notice that negative has gone away, I now have a +1, so I am good to go. So I'm going to split my equations. Again, I'll have 1 positive, 1 negative. And then I will solve like normal. Now, for these bottom two, we would choose one to be our quote-unquote number. Okay, so I'm going to do E with you. So this, I'm going to make my quote-unquote number. Okay, so this is the one where I will make positive or negative. So I will have my x plus 8 in absolute value bars is equal to 2x minus 6. And my two equations will become x plus 8 is equal to positive 2x minus 6. That did not change. Okay, but when I do the negative version, I have to put those parentheses around that entire equation because I want to make this entire thing negative. I don't just want to make that 2 negative. I want to make this entire thing negative. Okay, so then my negative equation will be x plus 8 equals negative 2x plus 6. And again, I will solve all the way down with that one. Okay. Word problems. They work the same as absolute value equations, but your setup has to be correct. Otherwise, you screw up. Okay, so x minus goal is equal to our wiggle room. Okay, so here for this word problem, I'm going to do with y'all, the recommended weight of a soccer ball is 430 grams. Okay, what we notice is it said recommended weight of the soccer ball is 430 grams. Grams. What that means is that is our goal. We will have x minus our 430, because that is telling us, hey, I want my soccer balls to be around 430 grams or they're not legal to play with. Okay? But it also says, since we're in the real world and we're not perfect, the actual weight is allowed to vary by up to 20 grams. So what that tells me is, since we're not in a perfect world, we're allowed to vary, which means we're allowed to wiggle. Okay, so we will have our equal to sign, and our wiggle is 20 grams. Okay, and from here, we'll treat this like a normal absolute value equation. We'll have x minus 430 is equal to positive 20, and x minus 430 is equal to negative 20, and then you would solve like normal. Okay, so that's a quick review on how we work absolute value equations. I know that's been a minute since we've talked about that. So let's move on to absolute value inequalities. Woohoo! Okay, they work really, really similar, but the main thing you want to remember is when you break it up into two equations, you are flipping that inequality sign when you are dealing with absolute values. So I'm going to go ahead and work this guy right here. So 6b plus 4 is less than negative 8. And, oh, I apologize. Can we be ever less than a negative? Okay, I notice that we have absolute value bars by themselves and we are less than a negative. What can an absolute value never be? Everyone together? It can never be negative. Okay, so if I'm less than a negative, that's just more negative. So this one's no solution. Woohoo, less work for us. All right, let's go ahead and work D then. Okay, so what I noticed first off is D is not completely by itself. I have that 5 out in front. So I'm going to divide by 5 because that is what my 5 is doing to my absolute value of x minus 4. So I'll have absolute value of x minus 4 is greater than 4. Okay, and from here, I'm good to go. I don't have any negatives anywhere. I'm good to go. Okay, so I'm going to have x minus 4 is greater than 4, and I will have x minus 4 is less than negative 4. Okay, so again, when we're doing that split for our equations, one of those signs flip for our negative. Okay, so moving on down to our absolute value inequalities. Again, this is very, very similar to the absolute value equation and formula. It's still x minus goal. Okay, that did not change, and then we have wiggle room. But we will have some sort of inequality in between. Okay, and that just depends on the wording. Okay, so reading this first word problem, the rules for a book report say that the report should have 300 words. Okay, it should have 300 words. So that tells us is that's our goal. We want our book report to have roughly 300 words. Okay, and it says with an absolute deviation, which is a very, very fancy word for vary, okay, of at most. Okay, at most means we are less than or equal to, okay, because it is telling us we cannot be more than 20 words off, okay. So our less than or equal to, and then we'll have our 20, because that is how much we're allowed to vary. And again, you will split that up like normal. So we'll have x minus 300 is less than or equal to 20, and x minus 300 is greater than or equal to negative 20. Okay, so you would solve those like normal and get your two equations. All right, moving on down to notation. Okay, when I have a normal inequality sign, so less than or greater than, okay, we use parentheses because we would have like some sort of open circle. And then when we have that equal to sign, we have our brackets. Okay, so I'm going to go over a couple of examples. I know it's been a minute since we've talked about this. Oh, excuse me. So I notice here that I do not have a line underneath this guy. So I know I'm going to have some sort of, whoa, what the heck? Sorry about that if you get motion sick. I have no idea what just happened. Okay, so we notice that we do not have an equal sign underneath this inequality right here. So we will have a negative 3, and we're going to have a parenthesis around that negative 3 because we do not have an equal sign. And then we will move to our 14, and we notice that we do have that equal sign, so we're going to have that lovely little bracket. Okay, you do pretty much the same thing here. All right, moving on down to, let's do this guy. Okay, so if I'm less than 20, what that looks like on a number line is I'm going to have my 20, and I'm going to have an open circle, and I'm only going to be on the left side of 20. And if we keep going forever and ever and ever in the left direction, we are eventually, well, we're never going to reach it, but we'll go to negative infinity. Okay? Now, what I want to note that is important is when we're dealing with negative infinity is the smallest quote-unquote number we can ever have. Okay? So we're going to start there. Okay? And then we move to 20 because we can't go past 20. Okay? Similarly, over here, if we were to draw this on a number line, okay, we'd have our 10 and we'd have a closed circle. And we would only be on the right side of 10. And again, we would go to positive infinity. But positive infinity is the biggest quote-unquote number that we can ever get to. So we're going to start at 10 and we're going to have that bracket because we have that greater than or equal to sign. And then we're going to go to infinity. And because we can never touch infinity, we will have our parentheses. Okay, now we go backwards. Okay, so if I were to write this first guy on a number line, okay, x is less than or equal to 3. Okay, the reason why for the less than or equal to is I have a bracket, and I know that I'm less than because I'm going to negative infinity. Now, for this other one, we're going to have negative 3 is less than or equal to x, which is less than 7. Okay, we're just going to read left to right on that guy, and we'll influence our signs based on the parentheses or the brackets. All right, moving on down. So this is the newest part that I had to show y'all today. And I know I showed every single one of my classes this because, again, we are not allowed to use Desmos on the DCP, so I had to teach y'all how to use your TI-84s. And, again, I will talk about this day of the test, and I can't really show you how to do this on my calculator because my calculator is dumb. So we will definitely be talking about this day of, and I will definitely refresh your brains. So don't worry too much about this method. Day of the test, we'll talk about it. Other than that, I think that was all I really wanted to talk about for this. I hope you enjoyed the review. Again, please like and subscribe to my YouTube channel. So I think that was it. So hope you everyone has a great night. I will